Okay, so we revisit a bit what we did in the last class and then we'll continue further. We were talking about sequential circuit testing, right? Combinational we talked of, sequential we started, and we said that the issue with the sequential testing is the flip-flops. If I have this flip-flop, in addition to the combinational circuit, suppose I have a combinational circuit में एक PI होता था, that is your primary input, एक PO होता था, that is your primary output. If there was any fault within the combinational circuit, I had to simply read that fault towards primary output and then judge its value, justify its value towards primary input. Now the problem exists that I have an added flip-flop. We considered only D flip-flop, synchronous flip-flops, single clock. So the output of the combinational circuit may be entering some D flip-flop. The output of the D flip-flop, which I call Q, is given to some part of my combinational circuit now. So in addition to this PI and PO, I have some secondary output and I have some secondary input as well. Secondary output को observe कब करेंगे हम? पहले secondary output will produce a secondary input. Then the secondary input will be given to the combinational circuit, which will generate a PO. Because we can only observe primary output, we can only control primary inputs. So this cycle has to be done. Since the flip-flops are working on a clock, during this cycle, at least one clock edge is to occur so that your secondary output is given back as secondary input. Right? तो इसका मतलब जो combinational circuit में we were working with a single test pattern, now we have multiple test pattern for a single fault. Case 2 में भी the fault exists on SI. अगर secondary input पर एक fault है, then it is quite easier for us to observe it because the fault on secondary input is given as an input to combinational circuit and we can observe the primary output directly. We considered this part, the fault on secondary input, in the last class. We studied that if there is a fault A which exists on this next state function, so that was easily propagated and we had two test patterns. So two time frames were used to test this circuit. Right? Now what happens? We look into another case that I have a fault here. This was the next state function. This was the OFB, output function block. So now my fault exists on output function block. Output function block का ये एक input है C. This C is taken up from E. E is fanning out into C and F. तो अगर मुझे C पर fault initialize करना है, so basically what I need is I need to ensure something happens at E. अगर मैं C पर stuck at 1 fault कह रही हूँ, तो इसका मतलब actual value should have been 0. Then only it will show a stuck at fault at 1. If this is the case, this simply means I need to ensure E equal to 0 होना चाहिए. ठीक है? Let us talk about time frame 1, the frame time frame 0, the frame where we are analyzing the output. हमें output मिल गया है, primary output is obtained. But अभी this is my secondary output, right? Secondary input. E equal to 0 is to be set when there is a clock edge. तो इसका मतलब at TF0 I need E should be equal to 0. Then only I can put up a fault C stuck at 1. Fine? इसका मतलब if I need E equal to 0, which simply implies in the last time frame, that is TF minus 1, इस time frame में ये जो value है this must be the value that was seen here. तभी clock edge आने पर the value will be propagated. So in TF minus 1 I should have D equal to 0. How can I put D equal to 0? D is the AND gate output from C and B, right? ये जो मैंने वैल्यू लिखी है C की, ये TF0 की है. अभी now we are talking of TF minus 1. So TF minus 1 means I do not know what the value of C is. This is a don't care, right? जब तक मुझे specific value नहीं पता है, I'll consider that every line has a don't care condition, right? तो TF1 में अभी C is don't care. What can you do to B so that you get D equal to 0? B equal to 0. So it means I should put B equal to 0. Right? ये मेरा fix हो गया. एक primary input I defined. What about A? A does not affect this. So I can put anything on A. If A is 1, this only governs the OR gate. If A is 0, again it only governs the OR gate. So it does not affect my D. So I can say my next primary input A equal to don't care. So in TF minus 1, if I put A as X, B as 0, I am able to get this value of D equal to 0. Right? So TF minus 1 में I gave the input as X0 so that I ensured D equal to 0. Now I apply a clock edge. It means I entered the next time frame, right? So now in the next time frame, this value of D gets propagated to E. So now I get E equal to 0 after the clock edge. You are getting E equal to 0. Now I can initialize the fault. Fault initialize किया मतलब यहाँ पर D bar put किया मैंने. By fault it is 1, by no error it is 0. Now I want this error to be propagated to D again. इससे पहले मैंने D को fix किया था without any error, but now in this frame I want this error to be propagated, right? Error कब propagate होगा? If this is D bar, when can you see D bar at small d? जब B equal to 1 हो, right? क्योंकि AND गेट का नॉन कंट्रोलिंग वैल्यू इज 1. अगर B equal to 1 है और C equal to 0 है तो आउटपुट वैल्यू 0 हो जाएगा. स्मॉल d will be 0. If B is fixed at 1 and C becomes 1 by fault, the output will be 1. So it means D will show me D bar now, right? So मेरे पास initialize किया मैंने fault को. If B equal to 1 put किया, then small d will show me the fault. It means fault is propagated to secondary output. But
आपने यही बोला ना कि अगर B में 1 देंगे और ऊपर C में 1 होगा तो 1 आ जाएगा, 1 से पता लग जाएगा.
हाँ, ये ब्रैकेट के अंदर फॉल्टी वैल्यू है, राइट? और बाहर करेक्ट वैल्यू है. तो B तो मैंने फिक्स कर दिया है 1 इस टाइम फ्रेम के लिए. लेकिन अगर C पर नॉन फॉल्टी वैल्यू है यानी 0 है तो स्मॉल d विल बी 0, और अगर C पर फॉल्टी वैल्यू है 1 है तो D will be 1. It means my fault will be propagated because I'll see a different output, right? So small d will have capital D shown. इस केस में मैंने small b equal to तो 1 put किया है, but what about A? What should I do with A? Because every time I have to define the primary inputs, उनको कुछ value देना है. Again I can give A as don't care because A is simply affecting my OR gate, which is not affecting my this part, and so I put A equal to X. So look at the two test patterns. सबसे पहले आपने X0 दिया था, right? अभी आपने X1 दिया, but the problem is still we are not getting any primary output observed. Primary output पर अभी भी fault नहीं आया है because you initiated the fault on C, which is a fan out branch. C का fault is not affecting F. F will get its input from E, right? तो अभी मैंने TF minus 1 में I initialized this fault and small d becomes d bar. The fault has propagated to small d. But now I want it to be propagated to E. तो इसका मतलब मुझे एक और क्लॉक एज देना पड़ेगा, राइट? एक और क्लॉक एज दिया तो दिस फॉल्ट डी बार विल बी प्रोपोगेटेड टू ई. तो अब ई becomes 0 1, faulty 1, non faulty 0. This is observed as F. So now my F is representing the fault D bar. Fault मेरी यहां तक आ गई. Now I am required to observe my primary output at G. So OR gate में when will this fault be propagated? What should you put the value of A so that only the value at F affects the output? 0. OR गेट के लिए 0 is non controlling value. तो इसका मतलब इस टाइम पे I should ensure that A becomes 0, right? A equal to 0 होते ही D was 0 bracket 1. तो अगर D faulty है तो G will be 1, और अगर F पे fault नहीं है, input is 0, then the output G will be 0. Since the two are different outputs, so it means my fault will be observed at primary output. When F has a fault, the value at F is 1, A I have fixed at 0. So OR gate ka output will be 1. If there is no fault on F, then the input value of F is 0, bracket के बाहर वाला. The other input I have already set to 0. So OR गेट का इनपुट 0 0 होगा तो आउटपुट इज 0. हमने कहा था फॉल्ट तभी डिटेक्ट होगी जब आउटपुट अपना वैल्यू चेंज करेगा. तो अगर फॉल्ट होगा तो आउटपुट बिकम्स 1, अगर फॉल्ट नहीं है देन आउटपुट इज 0. सो माय फॉल्ट हैज बीन प्रोपोगेटेड टू प्राइमरी आउटपुट. नाउ माय प्राइमरी आउटपुट विल शो मी डी बार वेरिएबल. डी बार हमने कहा था नॉन फॉल्टी 0, फॉल्टी 1, right? It means how many cycles did I use? I used 3 cycles. First, I started with TF0. I expected to analyze the output, but here I am not analyzing the output, right? So this was a false assumption. But when this cycle continued, I analyzed my fault here. If I put A equal to 0, I observed my primary output G as D bar. But this is sure I have put A equal to 0. What about the other primary input? What value should I give at B? Don't care, right? B को don't care दे देंगे क्योंकि वो वैल्यू यहीं तक आएगा D तक. प्रोपोगेट तो कब होगा, सर्किट को अफेक्ट कब करेगा, जब अगला क्लॉक आ जाए. Since we are analyzing here, so I can give B equal to X. So this becomes my time frame TF0 when I am analyzing the output at PO. This becomes my TF minus 1 where I did something so that I get the signal seen at the NSF of my circuit. उससे पहले I had TF minus 2 as well, time frame minus 2 as well, so that I initialize the conditions. So now if the fault existed at OFB output function block, I required 3 टाइम फ्रेम्स. पहले टाइम फ्रेम में आपका टेस्ट पैटर्न क्या था? इन TF minus 2, the test pattern is X0. Then I need to put my test pattern to X1 here, right? और एक्चुअल टाइम फ्रेम में जब मुझे आउटपुट पर फॉल्ट मिलेगा, what is my test pattern? A equal to 0, B equal to X. So now I have to have 3 test patterns applied to detect a single fault, which was not a case in combinational circuit, which was not in the case in the previous class where I had this stuck at 0 fault, because this stuck at 0 can directly be seen at primary output in TF0, provided I get the fault effect on F. Right, so I used only TF minus 1 and TF0 and I observed my fault at output. Fine. So the conditions become very difficult when the fault is seen at the output of a flip-flop. क्योंकि पहले मुझे उसका प्राइमरी इनपुट सेट करना पड़ेगा, फिर अगर ये आउटपुट ऑफ फ्लिप फ्लॉप इज डायरेक्टली नॉट कनेक्टेड टू प्राइमरी आउटपुट, then I have to move a complete cycle so that its effect is propagated to primary output. ये तो बात हुई जब एक फ्लिप फ्लॉप था, so you required 3 टेस्ट पैटर्न्स. अगर एक से ज्यादा फ्लिप फ्लॉप होंगे, you have more number of test patterns applied for a single fault to be detected. Right? So complexity keeps on increasing as I increase the number of D flip flops. और definitely D flip flop का number तो ज़्यादा होगा, because we say this is 1 bit memory. We are working with large memories, so D flip flop number would be very, very large. So it becomes very difficult to detect or detect faults for sequential circuits. We'll do one more circuit again for sequential, and then we'll talk about the observability and controllability to check mathematically how difficult it is to check for a particular fault for combinational and sequential circuits. Let's look into another circuit first. Again, 2 flip flops now. Fine. One thing more. We define the sequence depth for any gate or any flip-flop as the number of cycles it requires to generate the required output. Right? तो अगर मैं इसकी बात करूं, एक cycle में it is able to propagate my output, so the D sequence is 1. Right? Here, an output from here, C, an input at C affects D. The input at D affects E, which affects F, which again affects I. So the effect of C is has reached I in 2 clock cycles. So the D sequence of this flip-flop will be 2. The sequence depth is 2. Here the sequence depth is 1. Right? जितना ज्यादा सीक्वेंस डेप्थ होगा उतना ज्यादा हमें कॉम्प्लेक्स आउटपुट मतलब टेस्ट पैटर्न डिटरमिन करने में उतना ज्यादा कॉम्प्लेक्स रहेगा. राइट? सो इफ माय डी सीक्वेंस इज 2 हियर, इट मींस at least 3 patterns. The sequence depth plus 1. These many number of patterns will be required to detect one fault. Right? Let's analyze this. The fault to be analyzed is, say, J stuck at 0. Okay? J stuck at 0 means the value at J needs to be propagated to K, the output. When will this value propagate? What should I do to the other input of the gate? When will the error at J propagate to K? What should I do at H? What should be the value at H? 0. OR gate hai, so the value should be 0. So I need the value of H equal to 0, so that the fault here, which is D, actual value 1, fault 0, this value gets propagated to K. Right? So I want H equal to 0. When will I get H equal to 0? Justify the value, move towards primary input and find the value of primary input which ensures H equal to 0. So when will H be 0? When G is 1. If G is 1, E has to be 1. When will E be 1? B and D dono 1 hone chahiye. So this should be 1, this should be 1, but D is the output of flip-flop. इसका मतलब इससे पिछले टाइम फ्रेम में C should be equal to 1. So एक टाइम फ्रेम में काम नहीं हुआ, हमें पिछले टाइम फ्रेम में जाना पड़ा. Right? Talk about the upper end. If I want the non-faulty value 1 to be seen at J, what should be the value of I and A? 1, 1 each. So I have this 1, I have this 1. But I is the output of the flip-flop. It means पिछले clock cycle में I should ensure F equal to 1. So I write the पिछला clock cycle or पिछला time frame with another color. And let us say green. So पिछले टेस्ट साइकिल में F should be equal to 1, राइट? लेकिन एक पिछला क्लॉक साइकिल हमने यहां भी बात करी है, ये तो लकीली दोनों 1 आ गए, राइट? लेकिन अगर ऐसा हो सकता है कि ये कभी 0 आया हो किसी और सर्किट में, so at least 2 clock cycles will be required here to maintain this value, राइट? तो इसका मतलब अगर यहाँ पिछले क्लॉक साइकिल में 1 आया था तो वो 1 यहां से आना चाहिए, वही 1 यहां से आना चाहिए। इसका मतलब और पिछले क्लॉक साइकिल में यानी TF-2 में, जस्ट अ मिनट, हेलो, नहीं कल है क्या? 8 नहीं। So in the another previous test time frame, the value 1 should be seen at C. So I write this in blue color. Third time frame, I put it as blue. यहां पर मुझे 1 मिलना चाहिए, ठीक है? तो अगर मैं ब्लू वाली साइकिल की बात करूं, द लास्ट
मैम ये थर्ड साइकिल होगा।
हाँ, TF-2 मतलब, ठीक है? रेड इज TF0, green is TF-1 and blue is TF-2, right? I write TF-2 here. तो TF-2 पर मुझे इनपुट्स की क्या वैल्यूज देनी है? What should be the value of A, what should be the value of B and what should be the value of C? चेक करो। A don't care because right now I am working with this blue cycle. I need to have C equal to 1 ensured. Also, I should have B equal to 1 because I need to propagate this value and then this value should get ANDed. It should not change. So in the here I should ensure, no, B can be don't care ना, B 0 है या 1 है, अभी तो मैं केवल यहां पर इवेल्युएट कर रही हूँ ना C पर। In the next clock cycle, C will be propagated. Then I need to look at B. अभी तो I am not interested in B because I simply want कि मेरा C equal to 1 हो जाए in TF-2, which I can propagate in TF-1. So I can have B equal to don't care. What about A? Don't care. Right? Don't care 1. So I ensured in TF-2 I see C equal to 1. Now I apply a clock edge. At this clock edge, the value of C gets propagated to D. So I come into TF-1. Now I got D equal to 1. Right? Clock edge पे propagate हो गया. I should ensure B equal to 1. So I should have B equal to 1. What about A and C? A don't care. C 1 या don't care? 1. Why C1? क्योंकि यहां पर अगर मैं इस टाइम फ्रेम में 1 नहीं रखूंगी तो जो TF0 पर वैल्यू आएगा that will change. Right? I want C equal to 1 here. Why? Because C equal to 1, which when propagated at the next clock edge will ensure that the value D remains 1 in red. Otherwise, यहां अगर मैंने C को डोंट केयर कर दिया और ग्रीन टाइम पर वो 0 हो गया तो क्लॉक एज आते ही स्मॉल d विल बिकम 0, ठीक है? दैट विल क्रिएट प्रॉब्लम बिकॉज मेरा आउटपुट रेड E1 नहीं रह पाएगा. सो आई शुड एंश्योर C equal to 1. The clock edge exists now. The value gets propagated. This one gets here. This is evaluated with A, B. So A is still X, B is 1. So 1, 1 gives me 1 at E. This E gives me the value of F. It means at this time I got F equal to 1. This F equal to 1 gets propagated at the clock edge and this value of F goes to I. Right? So up time frame 0 means in red. Time frame 0 par I got I equal to 1. What about A now? I should make it 1 because I want this value as 1. So I should put A equal to 1. If I get A equal to 1, I equal to 1, the fault will be activated at J, which will be reflected at K if I have H equal to 0 in this cycle. If I want H equal to 0, what should I get? I should have 1 here, which means I should have 1 here and 1 propagated from the last time frame. So I need in this time frame B equal to 1 as well. Then only I will have this H equal to 0. So at this point of time, I should have B equal to 1. C becomes don't care because whatever change happens at C, we are not interested in it for this time frame because that will be propagated in the next time frame. So it won't affect my analysis in TF0. Right? So TF0 pe pattern ban gaya 1, 1, X. So what test patterns finally did we use? In TF minus 2, the test pattern was X, X1. In TF minus 1, the test pattern was A equal to X, B equal to 1, C equal to 1. So X1, 1. And what about the third time frame? 1, 1, X. So now I have to apply these 3 test patterns so as to detect the fault at output. I have 2 D flip-flops, so I need at least 3 test patterns to detect my fault because the D sequence, the sequence depth is 2. It requires at least 2 clock cycles for the primary input to be propagated maximally towards primary output. Is it okay?
यहाँ पे हमें पता लग गया कि अब नेक्स्ट वाली क्लॉक साइकिल के अंदर हमें सी की मतलब लोड क्या था इस वाले क्लॉक साइकिल नेक्स्ट वाले के लिए फर्क पड़ेगा तो मतलब थोड़ा लेट क्वेश्चन है बट ये है कि क्या ये साइकिल वापस ऐसी रिपीट होगी अगर रिपीट होगी तो फिर तो बानी होना चाहिए था
साइकिल रिपीट क्यों होगी हमें तो फॉल्ट डिटेक्ट करना है फॉल्ट डिटेक्ट हो गया इन 3 टेस्ट पैटर्न से तो अब मैं क्या करूंगी अब मेरा सिमुलेशन रुक जाएगा and with these 3 test pattern again using your deductive and concurrent simulation methods I will detect what other faults can be detected using these test patterns. I will eliminate those faults now. Right? मान लो तुम्हारा A stuck at 1 was able to be detected. So when I analyze the next cycle for my circuit, I will not analyze for J stuck at 0. I will not analyze for A stuck at 1 because the 2 were detected using a particular previous test pattern. So now I will restart my circuit, restart my simulation, but I will consider some other fault. So other fault karte hi test patterns will change. Right? This is the basic way we are testing the circuit. आप एक test pattern generate करते हो using any of the methods. Combinational है तो D algorithm use कर सकते हो, path sensitization use कर सकते हो, और एक और कौन सा किया हमने? We did one more.
Difference equation.
Difference equation, yes. You can use the difference equation method. तो आपने एक test pattern generate कर लिया. Now use any of the simulation method and find out what other faults can be detected with the same test pattern. So that my fault list keeps on reducing and I am able to have a less number of test patterns generated to detect all the faults. The aim is to detect all the possible faults in my circuit. स्टक एट फॉल्ट ही हम फोकस करेंगे, ब्रिजिंग फॉल्ट और अदर फॉल्ट्स नहीं करते, बिकॉज इफ वी एंश्योर दैट दिस स्टक एट फॉल्ट इज covered fully 99.9%, the other faults also get detected, क्योंकि कोई भी फॉल्ट हो उसकी वजह से वैल्यू स्टक हो जाएगी. तो इफ आई एम बेसिकली वर्किंग विद स्टक एट फॉल्ट, आई एम कवरिंग ऑल माय अदर टाइप्स ऑफ फॉल्ट्स. राइट. ब्रिजिंग फॉल्ट इज स्लाइटली डिफरेंट, क्योंकि फॉल्ट एक जगह स्टक हुआ है बट इट मे बी कनेक्टेड बाय डिफॉल्ट टू सम अदर वायर सो दैट द वैल्यू गेट्स प्रोपगेटेड टू दैट. Right, so we'll talk about bridging fault detection later. Abhi we'll focus on stuck at faults only. We saw it for combinational circuits, we saw it for sequential circuits. Now theoretically हम कह चुके हैं कि हमें ये प्रॉब्लम होती है sequential circuit में. The number of time frames, the number of test pattern is large, right, as the number of flip flops increase. Now mathematically, how do we say how difficult it is to detect a particular fault? For that, we talked about two quantities, two measures, observability and controllability. Observability क्या था? Observability was the difficulty with which my fault is seen towards primary output. Right? अभी यहाँ fault जो है वो केवल एक गेट पीछे था, so I should have expected कि TF0 में ही ये fault effect दे देना चाहिए, because this is very close to primary output. But practically we saw that it required 3 time frames to show its effect. Right? So this is very difficult. It seems easy that it should be easily seen at primary output, but actually it is difficult because it requires 2 time frames work previously. Right? So this is observability. How difficult is it to observe your fault towards output? Controllability means if I want this fault to be initiated here, I should justify the value 1, which is non-faulty value. How can I justify? Again, I needed 2 time frames back so that I control this value to be equal to 1. So we defined controllability as the difficulty to ensure a particular value on the given line. Right? In the next class, we will begin with the mathematical analysis and try to find out the mathematical value of this observability and controllability to indicate how difficult it is to control a particular line and observe the fault at that line. For that, we will have different mathematical formulas which we will be using first for combinational circuit, then for sequential circuits. ठीक है? But how will you measure? How will you write it? That we will see in the next class. Right? We'll have some mathematical values. 1, 2, 3, 4 करके values होंगी. 4 means ज़्यादा difficult है. 1 means it is easy. ये जो चीज हमने यहाँ पर exercise करी है, how to write it in your examination, I'll put something here. So you will analyze firstly for TF0. Right, for TF0, I need to have, what is this wire? H. H should have been equal to 0. At the same time, I should have J equal to D. For J equal to D, I should have I equal to 1 and A equal to 1. For J equal to D, I need I equal to 1 and A equal to 1. So A is my primary input. Right? I equal to 1 इस frame में नहीं आ रहा है. So I need to set this in TF minus 1. ठीक है? यानी now I talk about TF minus 1. अभी मैंने केवल एक primary input specify किया है. Right? We'll talk about the others when we keep on cycling. In TF minus 1, I need to have So in this cycle, set this in TF minus 1 by putting F equal to 1. तब वो propagate होगा I equal to 1 in TF0. Right? So I need to have F equal to 1. F equal to 1 कब होगा? E equal to 1 होना चाहिए, which implies B should be equal to 1 and D should be equal to 1. B तो हो गया मेरा primary input, right? D equal to 1 output of flip flop है. This I need from last time frame. This is to be obtained from TF minus 2. So it means now you work with TF minus 2. TF minus 2 में I want C equal to 1 to be set. Right? तो इसका मतलब C equal to 1 ये तो हो गया मेरा primary input जो मैंने set कर दिया. What about A and B now? Don't care. So it means at this point A is don't care, B is don't care. I set the value of C which gets propagated after the clock edge, right? So from TF2 I moved to TF1 at clock edge. So I ensured D equal to 1 is set, B equal to 1 हो गया. What about A and C now? A was don't care क्योंकि A तो इफेक्ट ही नहीं कर रहा है, since not affecting, and C should be equal to 1 since the value should not change in the next clock, since value at D should not change after next clock. So that the value of E is still 1 after the next clock edge. ठीक है, मेरे तीनों इनपुट स्पेसिफाई हो गए. Now I apply the clock edge and I move towards TF0. ठीक है, इस केस में A equal to 1 तो है ही. What about B? B should be equal to 1. क्यों होना चाहिए B equal to 1? Since नहीं, यहां तो B don't care हो जाना चाहिए. अब तो मेरा वैल्यू तो प्रोपोगेट हो गया ना. नहीं, I equal to 1 हाँ सेट हो गया मेरा. D is to be obtained from TF2. ये मुझे obtain हो गया. मैंने एनालाइज कर लिया E, F, G. So I put F equal to 1 here. ये सेट हो गया मेरा. Now at this clock, this F equal to 1 gets propagated to I. So I got I equal to 1. This I set in time frame 1 minus 1 and I got I equal to 1. अब I equal to 1 आ गया तो I simply want A equal to 1 ना, ताकि अच्छा H भी तो चाहिए. ठीक है ठीक है. So A equal to 1 करते ही तो J equal to 1 हो गया. At the same time I want H equal to 0 as well. So H0 कब होगा? जब G1 होगा, G या E1 होगा. E को 1 रखने के लिए मुझे B has to be 1, right? Since B has to be 1, since E should be equal to 1 during this clock cycle. Fine. So अब मेरे C क्या हुआ यहाँ पे? तीसरा वेक्टर डिफाइन करना, तीसरा इनपुट X. Right, so we analyzed it. First we moved from TF0 to TF2, then I moved from TF2 to TF0 again and I specified all the inputs. पहले जब मैं TF0 से TF minus 2 आ रही हूँ तो I am working with only required primary inputs. जो जो चाहिए थे वो I specified. But when I moved back from TF minus 2 to TF0, I worked with all the rest of the primary inputs as well. So at the end, I will have the 3 test patterns completely specified and the answer would be written in sequence by default. Right? So when we start reading, what we say is TF0 per I want H equal to 0, J equal to D, for which I should put A equal to 1, B equal to 1 and C equal to X. If I put this input values, I ensure that in this time frame E equal to 1 and the value F equal to 1 has been propagated from the last time frame. What happened in last time frame? To get this F equal to 1, I ensured that A equal to X, B equal to 1, C equal to 1, so that I have E set equal to 1, which gives me F equal to 1. Right? But during this time, I also want D equal to 1, which can be set only in the previous time frame. So we move to the more previous time frame, and in order to set D equal to 1, I should have C to be equal to 1. Right? I can write here so that D equal to 1 in next time frame. At the same time, A and B should have been don't care. Right? So the last statement is finally the test pattern sequence is 11x followed by x11 followed by xx. Okay? Here we stop. Fine. Tomorrow we'll work mathematically with observability and controllability. Online students, any problem? Who do I have here? Shamli and Saloni. ठीक है. Online students, you may leave.